Oh, I guess this one wants us to evaluate. All right. The negative. Don't worry about the negative. It's part of the numerator, by the way. If you, for some reason, if you wanted to, you could rewrite this as a radical, which has an index of 2. That's a square root, right? That's from the denominator there. Then that would be 4 to the power of that negative 5 numerator, right? Now from this, you would usually just reciprocate that, right? So we would show this as over 1, and then you can reciprocate that negative exponent. Of course, it keeps the square root there. Yeah, the square root, yeah, you don't have to show that one. But now, after flipping this, I now have 1 over the square root of what would be 4 to the power of positive 5, right? Because the 5 becomes positive after flipping that fraction. I just flipped the whole fraction right here as over 1. If you made this a square root of 1 over 4 to the power of 5, the square root of 1 is 1, so you end up with the same value here. I guess inside I really wanted to skip some steps. In any case, right here, let's evaluate that 4 to the power of 5, by the way. Here's what I want to do. I want to do this. I just worry so much. So, yeah. I'm going to take a quick shortcut to that, though. So my power of 5, right? Geez. Let's do this. Okay, so I got 4 to the power of 5 square rooted, right? So that's going to be 4 to the power of 5 over 2 on this. Here's what I'd like to do is change my base so that it's something that works with the power of 2. Why am I doing that? Because it should simplify much easier that way. The 4 right there, I'm going to make it 2 to the power of 2. Now, why would I do that? It's because I got 5 halves as another power there, right? So then the 2's become a phantom 1, and then you just end up, let's give ourselves more space. But then you get 1 over 2 just to the power of 5, which I can solve that. That ends up being 1 over 2, 4, 8, 16, 32. And that's even more simplified, which as a math nerd makes me feel better. There we go. Okay, now that was great.
You wanted that answer?
Part of our problem here is that students don't see this 4 as 2 to the power of 2. Try to look for those. Try to look for those, especially since this was, see how the denominator was 2? Usually if that's the case, I shouldn't say usually, sometimes if that's the case, then this base is something that can be raised to the power of 2, and it gets rid of that fractional exponent. So if I saw that it was like a 3, I would look for something that's a perfect cube here, right? And you just put in the calculator cube root of that and see what you get. Or in this case, the square root of 4 to see that it's 2 to the power of 2. Now, the other way you could have done this, sarcasm, I'm purposely putting it in here, but you could have typed in 4 and then put in the exponent button. And then you could have typed in the n over d button, and then the calculator would let you put in a fractional exponent. And then you could have typed in 5 over, so you went down to 2 and then pushed enter. Let's see what this gives us. 4 exponent n over d, negative 5 over 2, enter. You'll never believe this, but it gave me this.